Hello and welcome to Arduino Programming Fundamentals. My name's Doug. I'm going to be hopefully teaching you how we can do some basic programming with Arduinos, from just flashing a simple LED to making some robot motors move and using ultrasonic sensors so we can make the robot kind of go in different directions. Before we kind of get started with the Arduino, I just want to quickly mention a bit about programming languages. Now, programming languages, there's a lot out there, from machine code right through to C to Python, lots of others. Arduinos tend to just use C, and that's what I'll be focusing on. But all programming languages have the same core concepts. It doesn't matter which one you're learning, they will all have the same logical instructions in them. So for example, all programming languages can do input and output, some way of getting data from the user or another system, and some way of outputting that information. They can all assign data into RAM, so that we can keep coming back to whatever data we've stored and use that later on. They can all do some form of selection, so if something happens, then take action. If I bump into a wall, then go backwards. If I've pressed the fire button, then shoot the gun, whatever it is. Repetition. All computer programs can do some form of repeating. For loops allow us to count through things, while loops will run while ever there's something happening, while something's true. I'll be showing this in demonstration a little bit later. Then math stuff. This is the bit that tends to scare a lot of people, but it's as simple as a bit of subtraction, addition, multiplication, division, some greater than and less than signs, and then a little bit of algebra. So in this example, A is equal to 2, B is equal to A times 2. We know A is 2, so 2 times 2 equals 4. If you can manage that, that's about as difficult as programming often gets. Before we go any further with the Arduino, we're actually going to go into Tinkercad. It's a great program for testing things without worrying about the actual physical electronics. So if we jump over to Tinkercad, you will need to make sure you've created an account and logged in. A lot of people just use Tinkercad for creating 3D models for printing, but there's also a little bit on circuits. So if I go into circuits, I'm just going to create a new one. Just start with a blank page, and I'm going to drag an Arduino in. If I drag the Arduino over, there we go. Now if you're not familiar with Arduinos, they have lots of pins. These pins can act as either inputs or outputs. We can turn them on, can turn them off. We can sometimes read the actual data coming in and the frequency of that data. But the one we're going to focus on right now is this LED. This little LED is hooked up to pin 13, so it's already on the board. It's a great little way of just testing to see if your system is working. So if I just go onto the code window, you see it's got a kind of a Scratch style interface for those familiar with Scratch. I'm not going to stay to that, I'm going to go straight into text. Yep. Now Tinkercad's kindly given us a bit of code already. There's two functions, one's void setup, one's void loop. The setup is where we initialize what we want to happen. At this point, LED, like I say, is hooked up to pin 13, so the pin mode has been set to an output. It is important you do this. If you don't do this bit, it may work and it may not work. It's erratic. Then in void loop, we've got this digital write command. Digital write just tells the pin whether to be on or off. So if we turn it on, we just use the high command. So it's saying pin 13, let's turn it on. Then we're going to wait 1000 milliseconds or 1 second. Then digital write 13 low is just turning the pin off. So there's no volts going to it. And again, wait a second. So if we just press run, we see the little USB cable goes in and a little light starts to flash. This is a perfect way of just making sure your system is working. If you've got a real Arduino, go and give it a whirl. So I'm going to stop that. Just to prove this is doing something, if I change the code and start it, we can see the little lights flashing a whole lot faster. Obviously a bit too fast, so I'm just going to change it. Do make sure you stop the simulation before running it, before changing the code. Okay, we can see it's going on and off again. Okay, like I said, I think this is a great way to just test code, make sure it's working properly before you go any further. Because once you start messing about with the real Arduinos, you know, a lot of you may have started with something like this. You know, if it doesn't work, there could be a problem. You may have made a little code mistake. You could have fried your Arduino if you've accidentally dropped a positive Y connection somewhere on it. You know, the Arduinos obviously come in different shapes and sizes. I'm a big fan of the Arduino Nanos. But again, you may have fried your Arduino. Your cable may be faulty. There are some cables that are for charging only, not for data transmission. Your USB port might be blocked. If you've got Cura open, it stops your USB and Arduino from actually talking to each other. I found that out the hard way. you might just not change the settings properly in the Arduino software, something I'll come back to in a couple of lessons time. But like I say, if you want to make sure it's not your code, it's the hardware, try in Tinkercad first. Okay, so our next lesson we'll be looking at adding some more Arduino lights, adding some switches and making some sound. So I'll come back to that lesson.